Sébastien, Jean-Thomas, can you close the door, please? Hello everybody, welcome to this new LAD 22. Welcome to everybody in person, but also in live, because we are live broadcasted. Of course, we would like to say some words about our sponsors. Without the sponsors, we couldn't have this kind of place. We cannot manage a great social event, I hope so. The first one is Atos, then CA, of course, DTN, HPE, Western Digital, and OneCloud. So, a quick numbers about the attendees we have. We are about 70 people for this 22 LAD event. We come from 11 countries, and we come from 38 different organizations. It means that LADS is interesting by many people and many countries. Perhaps it's just Leicester, of course. But I would like to say some word about people which are online, of course. I don't know about on the regi how many numbers we are right now. No numbers. Ludovic? Just 5 seconds. We'll have a number in 5 seconds. 11 people right now, like the number of countries. Quick general information. It's a 2-day workshop, as you can read on the agenda. The social event is this evening. I think nobody will forget it. The breaks will be served on this floor in front of the room. So no need to take upstairs or downstairs. Okay, it's fine. It's on the same floor. The exception is for lunch. The lunch will be served upstairs. So you take the stairs and you will have a huge, nice upstairs, and you will have the lunch room. Then about restrooms, they are on this floor. So just follow the signs. It's when you go out the room, it's on the left. And of course, the full event is live broadcast. So be careful at what you are going to say. Not the social event. We don't know, perhaps. So quick attention, please. Your badge is pretty important because it gives you access to food. Well, if you don't want to eat, it's not an issue. But quick attention for people we have some specific dietary. Just put on the table your badge, and you will have the food you have requested. Then your badge will be checked for the social event evening. It will be checked by a security agent. We had no choice, so all badge will have to check this evening. So don't forget it on the room. We try to upload the slide decks at the end of each talk as soon as we can. And at the end of the LAD, you will have a survey. Please fill up the survey. It's pretty useful to get improvement over the year. I think everybody has catch the Wi-Fi access point. It's Hotel Arrêt Métier, and you have to register on the Wi-Fi portal. You have to tick the checkbox chart in French, okay, to have the access. What does it mean? Chart. It's the rules, yeah. in English. You have to accept just you are going to use the internet of the building, and you have to tick. A quick word about the LAD 22 organization team. We have many people: Guillaume, Thomas, Laetitia, Karine, you have seen at the enter, Sébastien, Sacha, Ludovic, Jérôme, and myself. What I would like to say here is that nobody in this list, their main job are not to plan an event and organize an event. So we have all a job, and we do this plus our main job. So it's just a big job workload plus. Of course, I would like to tell thank you to attendees, to speakers. Without participation, without your registration, it will not be possible to organize this kind of event. Okay. A kind of French cliché on the picture. But we have one surprise. We had an happy birthday to somebody or someone in this room. So, who was born on September in this room? Nobody? Ah, Aurélien, perhaps. Okay, nice to meet you, Aurélien. It's just a joke. It's the birthday of Lad, okay? The baby Lad is 10 years old. So it means it takes longer, of course. We could achieve to manage this kind of event during 10 years, which is bit effort, but it means that this event is loved by a Luster community. Okay. So it's 10 years old. You have seen that we need many people to manage this organization. We'll take a short break, a short picture from people who manage the LAD from 10 years. So come on, guys, people from CA and last, before some people, come on the stage. Now. Ludovic, it's time for the picture. Karine and Laetitia. Sébastien, can you call Karine and Laetitia and yourself? Come on, guys. No, Sacha, you are not late. Come on. Laetitia and Karine? Yes? Un? No. No, un. Come on. Casquette. Casquette. Non, ça va pas de casquette. Ludovic? Cheese. It's okay. Thank you. I have finished the welcoming speech, so we are going to start with our first speaker.
So our first speaker is Peter Jones. He's been working on Lustre since 2006, and he's the co-lead of the Lustre Working Group, a director of the Administrative Council of EOFS, and runs the WebPlum Engineering Division at DDN.
Hi everyone, how does that sound? Hear me okay? Okay, very good. So just like to echo Gail's comments, just really good to be back here in person, and thanks so much for the CA team for putting on this event. I definitely agree, it's very much appreciated in the Lustre community, all the work they do to make this possible. So I'm going to give you a bit of an update about the Lustre community releases, and the Lustre Working Group is an organization which, as many of you may know, focuses on activities relating to the Lustre community releases. So myself and Dustin Leverman from Oak Ridge, the co-leads of that group, but it's open to anyone to participate. The mailing list here on your left, the URL on your left gives the links, which has all the details about the calls and the minutes of the meetings and the mailing list. So you could, even if you can't make the call, you can still follow along with what's being discussed and maybe ask questions via email or what have you. One of the activities we get involved in is compiling the questions for the annual Lustre survey. So you may well have seen a request to sort of complete that sort of every sort of February, March of the last sort of 10 years or so. You can see here, this graph shows the number of respondents we've had over that period. So it fluctuates a little bit. We generally get a fairly healthy number of people completing the survey, and we definitely do, that does help inform some of our decision making, the results we get from that. So we try and balance it so it's only going to take a few minutes to complete to try and encourage people to participate. So it isn't a great time investment, and it really is useful for us if you do take that time. So I did go into a bit more detail about this year's survey in my presentation I gave at LUG earlier this year, which perhaps more of you would have seen than usual because it was, a virtual conference. And the URL here on the right has all the historic results if you wanted to go and sort of do some wading through that. I'm just going to comment on a couple of specifics from that survey today, which I think are particularly relevant. So this is the Lustre version survey. So at the time that the survey went out, the 2.15 release wasn't out yet. So at that time, we see the similar pattern that we've seen over the years, that older versions, people, over the years, this is the last 3 years data together, you see stepping down as people upgrade or take older systems out of service, and strong coalescing around the sort of the LTS releases. So that's sort of 2.10 and 2.12 here. But the thing that was quite surprising was we saw strong adoption of 2.14 to the extent it actually overtook the 2.10 release this year in terms of the number of sites who had at least one production usage on that version. And since then, we've had the 2.15 release come out, and there was a question in the survey about how quickly people intended to move to that release once it was out, as we were anticipating it being soon. So the blue section on this pie chart is the people who indicated they planned to immediately upgrade to the 2.15 release once it was available. So 28% is a fairly significant proportion. I mean, historically, going back over the years, people were definitely fairly cautious about doing a major version upgrade, but clearly there's, as we saw from the adoption of 2.14, people, whether it's for features or newer kernel support on the servers or a combination of those, there's definitely some people who are very attracted to the move to something more current. Whereas, obviously the green and the red could be characterized as, wait and see type options. And so people are sort of interested to see what the early adopter experiences are like before making a firm decision about their own plans. We also, to summarize, I would expect to see in the 2023 survey strong adoption of 2.15, not to the extent of 2.12 still, but certainly probably that will be the second most common option I expect. And then we did ask a couple of qualitative questions of people to supply, thoughts about feedback. So when we're sort of trawling through those, sort of really looking for comments where there's multiple people saying largely the same thing, and we asked a question about the workings of the Lustre Working Group, and really most people just skipped that question, and the people who did complete it sort of maybe the feedback was not really actionable. So I really took that as perhaps most of the respondents weren't really that familiar with what's going on to really give an informed opinion. But much more people did complete about Lustre to provide some kind of opinion, as you would expect. So we did get a number of people making comments about stability without really sort of elaborating as to any particular areas of concern there. So I sort of took that as more of a indication that we have a mature feature set, and so there's no sort of glaring gaps that people are looking for, and they really would like to have more engineering focus on sort of doing what we're doing, covering different sort of edge cases and things, and really improving, which I think is broadly what we are doing. There was also a number of comments about from people who use Lustre on ZFS, saying that they wish that the LTS branch would move to a more current version of ZFS. So this is really perhaps just a sort of lack of awareness, or us not doing a good enough job in promoting that awareness, because we had with the 2.12 releases been including patches to allow people to be able to use newer ZFS versions, but we just hadn't moved the default version forward because there hadn't been strong enough feedback that people were using those newer versions stably in production. And so we always sort of err on the side of caution with the LTS releases in terms of what we backport, so that people can feel comfortable to move to those newer releases and don't suddenly get some unexpected, unwelcome surprise when they do so. We did have a couple of comments about people saying they wish there was some easier way to add and remove storage with Lustre, and which is, I think, fair comment, and is definitely something which is in our minds for possible future work. And there were a number of various comments about I'd characterize as either about specific kernel patches or support for people's favorite Linux distribution. And so with all those, I would say that basically we're kind of you have a lot of flexibility what you can use with Lustre. You're not limited to do where we focus our own testing centrally on, and many people are in production using other options. If we get sort of feedback that we should alter our focus, we definitely will. That's kind of one of the things where the survey is very useful. So going on to the specifics about the releases, so 2.12 is now sort of been around a while, very widely used, quite sort of mature, so the rate of changes there and releases has really dropped off. So we had the 2.12.9 release come out in June, which provided support for RHEL 8.6 clients, and so we're in the transition period now where we would, potentially could do releases for both 2.12 and 2.15. So it's pretty likely we'll have a 2.12.10 come out at some point. The most likely trigger being RHEL 8.7 clients. Of course, the exact timing of the Red Hat 8.7 releases, perhaps a bit uncertain, but it wouldn't be terribly surprising if there's one out by the end of the year that we then provide a 2.12.10 to cover support for. Similarly, we've had a 2.15.1 release come out last month, and with that we provided, again, support for RHEL 8.6 clients, and this slide's a little incorrect, that it's actually Ubuntu 22.04 clients was in that release. This is a slightly down rev slide. I made a couple of last minute tweaks. Unfortunately, didn't get those through. But with 2.15.2 2, we do have, we will be adding support for Red Hat 9 clients and SLES 15 SP4. We were initially hoping to have those in 2.15.1, but there was a little more work required, and we didn't want to delay the release for everyone for those. So that work has now merged. So if anyone's interested in experimenting or running testing, the tip of the B215 branch does have those changes that would allow you to build and run. Wouldn't recommend it for production until we have a fully qualified release, but certainly, if you're looking for some, to get an early read and perhaps provide some feedback, that's definitely an option. So 2.15, so the 2.15.0 release went GA in June, and we had a pretty lengthy release cycle for this release. I think because there was awareness that it was going to be an LTS release, we had strong engagement from the community with testing on release candidates, and we did have some issues raised that we sort of, dug into and held the release until we had resolved. Some of those issues transpired to be very sort of edge cases that potentially could have been hit on shipping releases that were already out but hadn't been, including very old releases. But as a result of that extra activity, the positive outcome is that we have the .0 release would be higher quality as a result. On the slight downside, it did mean as we go into code freeze, our policy is not to change the Linux distributions we're testing when we're in code freeze. Usually that period's only a matter of weeks, a few weeks. But as timing worked out, it was slightly extended. And during that period, I think every distribution we supported did issue a release. So when we had the initial release come out, it did look slightly out of date. We did then immediately resolve at least the most, some of that with the 2.15.1 release fairly shortly afterwards. Going on to the contribution statistics. So I did show some provisional data like this in my LUG presentation, but this is the final data from Dustin. So the graph on your left is code reviews, and the graph on your right is lines of code changed across different organizations. So this being a European event, I will sort of particularly spotlight the contributions from European organizations. So we have GSI from Germany, SUSE, and our host CEA, all participating in reviews. And on the actual code contribution side, again, SUSE, a very significant number of changes involved, and also we have Atos and Sanger in the UK also had some changes in there. So this is showing how the 2.15 release compares to sort of earlier releases over time. So I've shown this data in a tabular form previously, but I think putting it into a graphical form does make it easier to sort of see differences over time. So the graph on your left is about code change. So the upper blue line is the lines of code changed, and the lower red line is the number of commits in each given release. So you see there's fairly reasonable correlation between those two. And then if you look at the last point on the graph, the far right, you can see that 2.15 in terms of lines of code changed is relatively high compared to its predecessors. But I think that's more of a factor of the lengthy release cycle rather than, actual very significant changes having occurred. And then the graph on the right is contributions by developers and organizations. So the blue line is the developers, and the red line is the organizations that those developers work for. So you'll see again the overall trend there, I think, going right back to 1.8 is of a gradual increase, and there's sort of some fluctuation. And most people, even on a tabular form, people would often ask questions about the big spike on 2.9. And it really jumps out with, when you show it graphically. So you'll see there's no equivalent sort of spike on the lower organization line. And so what we had at 2.9 was essentially one particular organization flushed the cache, as it were, and we had a large number of, a backlog of some years of changes come up, which were largely very small, 1 or 2 line changes to test and such like, that did sort of rather inflate the overall number for that. But, broadly, if you ignore that anomaly, you just see a very gradual increase with some slight variation. So all this talk about contribution has probably got you all fired up. How can I contribute? So we've been talking about the development side of it, and we do have, there is information on the wiki about the logistics of that, and, you can talk to myself or Sebastian or Andreas, who, if you don't know who those are, they'll be presenting later today, the other two, and so you could talk to us about the logistics of that. But, I appreciate that's not going to be for everyone, but most people who use Lustre will have some interaction with the documentation. So if you're finding things in the documentation that could be improved, gaps, whatever, please let us know. There's a huge body, the manual's huge. There's also a great deal of material on the wiki site. And so, it's very easy for some things, we know if there's something new that needs to be put in, but it's very often, possible for things to gradually become, slightly stale or over time, and so, or have, some gaps that, people who are reading it new, it's easy for them to spot and to flag. So, if you're finding it difficult or not useful, and you flag that, that can help us fix that and make it easier for, people in the future not to run into the same challenges. Then sort of being involved in events, community events like this, even just attending is useful. It's really great to be able to network and chat directly with people who are using the software. Further than that, I do encourage people to consider giving talks for these kind of events. I think site updates, often when, chatting to people and you ask them that, and they say, oh, no one would be interested in what happens at our site, but then you talk to them and you're like, well, yes, they would. So I think it's just very, very valuable to have that kind of exchange and even giving a short 15-minute presentation about the Lustre users of your site, I think can be, other people in the community would appreciate that. Completing the survey, I've already plugged that, but again, I will mention it. The Lustre Working Group, again, the URL again of where you can get information about that. And then if your organization is not a member of one of the community groups, consider it's not a huge cost, but it really helps collectively for us to have these community organizations having the funds to keep active and to keep promoting Lustre out in the community. So again, I'm involved with both organizations, and if you're interested in what the mechanics are there, I'll be happy to chat with you about that. Moving on to 2.16, we're expecting that for the first part of next year. There's, Andreas, and we'll be talking a bit more about the development going on. We do sort of, typically for the roadmap, which is here, we tend to pull out sort of some of the bigger ticket items that we anticipate are going to be in a given release time frame to sort of promote that, but there's generally, a lot of very interesting sort of next stage evolution for stuff that's already there that, Andreas will go into a lot more detail about in his talk. And then just to see, on the roadmap here, we do show what the planning, switching over between the LTS release as well as the broad timing of the releases. As you can see, we're going to, as we're in a more mature sort of feature set sort of stage with Lustre, we're not sort of churning out the major releases every 6 months. We're more like sort of a year apart type timing now. And then I was thinking with the, it came up as I was putting this presentation together that there was somebody posted on the mailing list with one of those like, this is a common misunderstanding people have, and it struck me that I should use this opportunity to sort of just create some better awareness about these things that do seem to perennially come up, and just in case that there's anyone else out there who is unaware of these things. So one is that you should always use the latest E2FS progs if you're going to be running a file system check or something. You're not tied to the version that's shipped with at the time of your Lustre version coming out. Another one that seems to come up fairly often is people grab the largest tagged version that they can find, and that is often a development build, not a build that's been fully qualified and expected to be used for production. So if you're running 2.15.53, that is not better than 2.15.1. So anything over 50 is a development build, and you should be looking, expecting your number to be 10 or less for the final digit, and then you're in an official release. And then the other thing that comes up often is we find people are running, they're reporting some known fixed issue, and when you say, well, you're running 2.12.3 and that's fixed in more current 2.12 releases, they say, well, I can't move to that release because I have to use this specific kernel version. So even though we test with the latest kernel version at the time of a given release, that doesn't mean that you can't build the same Lustre code against a slightly down rev kernel version if you wish. And many people do that, and that seems to work fine. It could be a bit trickier if you went to a newer version than what had been tested. There could sometimes be something that breaks the build or some unexpected behavior. But typically, once we have a certain version that has been working at some point, it will continue to work. We don't, it shouldn't. Certainly with maintenance releases, you would expect that to be consistent. So it's always better to have the latest Lustre code, even if you're running a slightly older kernel version. So just to summarize, so 2.15.2 should be out by the end of the year, 2.16, sort of maybe Q2 next year, and the Lustre working group details are there. So that's me right now. Any questions either here, or are we able to take questions from the people watching on YouTube?
Maybe.
Maybe, okay. Well, anyway, for the people here in the
No
room...
question for now, online.
Sorry?
No question online.
No questions online, okay.
Sorry.
Yeah, and for people actually here, I'm happy to chat on breaks or, lunch or whatever as well, if people would rather ask questions then.
First of all, thanks to Peter.
Okay.
Any questions?
Hello.
Hi, Gwen.
Hi. Will you ever be supporting Ubuntu servers?
I think that falls in the category of if there's sufficient demand, we could do. But it's basically, with the server versions, in the past as well, we've had questions about SUSE servers. And so, generally there's a patch set there that builds and works. And James Simmons will be happy to chat to you about the joys of Ubuntu servers. But in terms of what we're focusing our testing on, we're really focusing on Red Hat and Red Hat derivatives because that's overwhelmingly what our customer base are interested in. So it's a bit chicken and egg there, I suppose. I don't really, I'm agnostic to it, but I only want to test one. It doubles the test matrix, right, if we do some other option.
James, would you like to add something?
Yes, I do regular testing and stuff. And actually, at the last slug, we gave a presentation about setting up a test system, just like what LambCloud does for external distributions, like Leonardo does it for their ARM. And if anyone in the community wants to actually tackle that, the Jean-Lin from ARM and I can talk to you about our experiences trying to set up a test system for external testing.
Right. I think the tricky thing would be is that Ubuntu can jump forward quite aggressively with kernel versions, and I think you would feel the pain of that a lot more rapidly on the server side. So whoever's signing up for that needs to be in it for the long haul, right? So anyway, was Thomas, did you have a question?
It's actually an online question from Nicolas Chauvet. You have mentioned testing Red Hat release ahead of general availability, such as 8.7. Do you find CentOS Stream useful for this matter?
We haven't used that. We do qualify as a Red Hat partner, and so we tend to use like beta versions from Red Hat ahead of the release. Not every release has one, but we've done that certainly with like Red Hat 9. We had some access to that ahead of time.
Hi. I see on the email lists some talk about the ARM versions.
Yeah.
Could you say a couple of words about that?
Yeah, I mean, there's been questions about having better, ARM support for years, and I will say the most recent effort from the engineers working on it presently has been great. They've really got engaged, and they've done some, fixed up some long-term, there's all kinds of things just on the tests, there's all kinds of assumptions in the tests, based on assuming it's x86, that means that tests always fail on ARM and things like that. They've gone through and fixed up a lot of that, and they've got got their own test system running, which will, we have in our testing already to do ARM clients. We've had that for some years, but they're also testing ARM servers as well. So yeah, it's definitely improved, and we've recently added a link. They've got some download from what they're testing when we have the releases, so you can click and download from there as well. So yeah.
Thank you. Any other questions? No.
There's another online question from George, who asks, can we safely assume that if it works on Red Hat, it will work with Alma or Rocky Linux?
Yes. I mean, in my experience entirely, I mean, we do actually test with Alma as well as Red Hat. We test, I was mentioning Red Hat specifically because that's where the original ones with the betas you would have, and then we do test with Alma as well, and we do have customers who are running Rocky, and we've not found any differences to date.
So one thing I noticed, if you go back to your slide about the graph, the time graph, contributions versus lines of code, you were saying that there's actually more commits. You had the graphs backwards. So in fact, the number of lines of change in 2.15 is basically static. It's just that there's more commits because of smaller patches. Right. So the blue line is the number of commits, which has grown up quite a bit. But in fact, the red line is the lines of code, which is relatively static.
I have them correct. I just described it wrongly.
Yeah.
Sorry about that.
Thank you. We have time for our last question. Perhaps online? No question. Okay. Thank you,
Okay.
Peter.
Thank you.
So our next presenter is Sébastien Buisson. He's been working on Lustre for 15 years. He initially in solution and development activities for Bull, but in recent years focusing on Lustre development at DDN. He's a recognized expert in the area of Lustre security within the community and has presented various topics on this area at Lustre conferences over the years. He currently works in the Web Cloud engineering division at DDN and is based in Grenoble.
Thank you. Hi, everyone. So with this presentation, I wanted to give you an update on the latest news about the Lustre client encryption feature, and also show ongoing discussions about currently identified limitations and how they could be addressed. Before we start, I want to say that this presentation includes a quiz. So this is going to involve you in the room and also you online. This is a quiz that is hosted online. This is live, and this is going to be competitive. So you will try to score as more points as many points as you can. And maybe you can win free drink at tonight's dinner party. It depends on the LUG organizers. Or maybe you could get self-satisfaction and pride. So this quiz is going to be hosted on the Kahoot platform. So maybe I will give you the login details later in this presentation, but maybe what you can try now is to have access to the kahoot.it website just to see if it works for you. So this is kahoot.it and not kahoot.com, so kahoot.it. And yeah, you can connect with your smartphone or your laptop. Either way works. Okay, so here is the outline for today. First, I'm going to explain what is exactly the Lustre client encryption feature and where we are with 2.15. And then the second part of the presentation will be dedicated to the currently identified limitations with the feature. So this is fit to pass and access to raw encrypted information mainly. And the purpose is to see how these limitations can be addressed. Okay. Let's get started. So you are probably already familiar with that. On kernel side, we do support the FSCrypt library that is provided with Linux 5.4. And if you are using the other distributions that are mentioned here, so these are the main Linux distros out there, you're going to use the embedded LLCrypt library that is included with the Lustre code. On user space, we rely on the FSCrypt command line utility to decide which directories are encrypted and how they are encrypted. So in 2.15, we have support for content encryption and also name encryption. Since my LUG talk back in May, we made a couple of enhancements to the Lustre client encryption feature. The first one is, so before that, it was already possible to use E2FS CK or DebugFS on an LDiskFS target that is hosting encrypted files. And now we have improved the situation and we are escaping encrypted names so that you can even mount your LDiskFS target and browse it without breaking your shell. So that's useful when you need to have access to the device. We also recently reintroduced the null encryption mode for name encryption, and in 2.15 this is the new default. So it means that for newly created encrypted directories, by default the names of the files and directories will not be encrypted. Of course you can decide to enable this feature, so there's a global tuning parameter. This is called enable file name encryption. And if you set that to 1, then the newly created directories will have names encrypted. So it only works for new encrypted directories. Another improvement is regarding compatibility between 2.15 and 2.14. So the 2.15 client is able to handle name encryption, but the 2.14 server does not understand that. So in order to avoid problems, there is now a connection flag. So automatically the 2.15 client is aware that it is talking to a 2.14 server. In this case, it is not using name encryption to avoid any problems. And the good news is that all these enhancements will be available with the 2.15.2 maintenance release that is that will be released later this year. Another recent enhancement is regarding performance with encryption. I already presented this performance optimization. It is targeting write bandwidth, and so it is using the, if you look at the internals, it is using the enc pool mechanism that is already here in Lustre for GSS support. And basically, this is a pool of page cache pages that are pre-allocated, and the pool can grow or shrink depending on usage. And so we modified the LLCrypt library that is included in Lustre so that it takes its bound pages from this pre-allocated pool instead of being allocated every time it is needed. So we are saving a lot of page allocations, and thanks to that, we have pretty decent performance. Here you have the right bandwidth performance, and as soon as you are doing 1 megabyte IOs or larger, the performance drop is between 5 and 10%. And as I mentioned, this performance optimization only works if you are using the embedded LLcrypt library, but this is the default one when you build your Lustre client. And good news, again, this is going to be available in 2.15.2. Okay, so now this is the second part of the presentation. This is about the identified limitations with client-side encryption. The first limitation is fit-to-path. So basically, fit-to-path is a mechanism inside Lustre to map file identifiers to path names on the global namespace. So it's very convenient, and it's used in many tools that work on top of Lustre. Problem is, this feature doesn't work currently with encrypted files. Okay, so now it's time for you to work a little bit. Let's see. So if you want to play and join the quiz, you have to go to the Kahoot.it platform and enter the PIN code that is at the top of the screen. For millennials, you can just scan the QR code at the top as well. And so you will be asked to enter a pseudo. And then when you have joined, we can start. So I'm sorry, this is limited to 50 participants, so please make sure you join now if you want to play. So I can see there are a lot of people joining. Thank you for that. I hope it will be fun. So you will have to find the right answer to questions, and you will have to answer as quickly as possible, because the quicker you are, the more points you score, and then you will win a free drink for tonight. So I will wait a little bit more. What else to say? No, it's just basically to test your knowledge of Lustre and common sense. Okay, so if you join, just one word, if you join using your smartphone, you may be disconnected once your screen gets locked. In this case, you just have to refresh the page, and it will be, you will be connected again. Okay, I think we can start the quiz. You can join anytime, so don't worry. Okay. So first question. So according to you, where do you think name encryption and decryption is carried out? So is it carried out on Lustre client side? Is it carried out on Lustre server side? Is it carried out on both sides, or is it carried out outside of Lustre? Okay, time is out. The right answer was, of course, Lustre client side. Quick look at the current ranking. Okay, question number 2. Where is fit-to-path resolution carried out? Do you think fit-to-path resolution is carried out on Lustre client side, on Lustre server side, on both sides, or outside of Lustre? So, time is out. The correct answer was Lustre server side. We will do a debrief.
Is there a price
okay.
if we are last?
I guess if you're last, maybe you will have a free registration for next year in order to improve your Lustre knowledge. No, I'm just kidding. Okay, question number 3, double points. This is a bonus question. Which key do you think is used to encrypt one file's name? Yes, this is a tough one. So is it the master key? Is it the per file key? Is it the parent key? Or is it the monkey? So the right answer was the parent key. So after 3 questions, oh, this is quite close between Simon, Adrian, and Stefan. Okay, so this is the end of the first part of the quiz, and now let's debrief. So, as the name suggests, Lustre client encryption is carried out on Lustre client side. It means that server side knows almost nothing about how to carry out encryption. On the contrary, feed-to-path is carried out on Lustre server side. It means that when you are doing LFS feed-to-path, the client sends the feed to the server, then the server builds the whole path and just returns a string to the client. And you have to know that when you have an encrypted directory with files and directories inside, all the encrypted names are encrypted with the same key, which is the parent key. So today, if you try LFS feed-to-path on an encrypted file, we made the choice to return INO data because the Lustre client code cannot understand raw encrypted data that the server would return in the current status of the code. But of course, we would like to address this limitation. And our proposal is to let the server return the raw encrypted information that has been built with all the path components on server side, but to encode that. And then the first thing that the client would have to do would be to, so I'm talking about the LFS feed-to-path command, it would have to parse the string that is received from server, so that would look like this example here. The encoding we use guarantees that there is no slash or null characters inside the individual components. And so the client would have to recursively call from top to bottom do the following. So first, decrypt the name, and if it's a directory, do a lookup on this name in order to retrieve the inode, and this inode is giving us access to the encryption key, and so recursively you call that from top to bottom in order to decrypt the whole path. So it means that with a normal file you have a single RPC operation, and for encrypted files it would be turned into multiple lookup operation. So this is going to be much more expensive for encrypted files if the name encryption feature is enabled. Okay, so let's move on. Let's talk about the other identified limitation with client encryption, which is access to raw encrypted information. For different purposes, we might want to be able to open encrypted files if we do not have the encryption key. We also might want to read or write encrypted files without the encryption key, or even get access to the encryption context and the raw encrypted name. But all these accesses are forbidden by the FSCrypt library. And this is some kind of limitation for us. So let me get back to the quiz. So I will let you reconnect. So if you are on your phone, please make sure that you've refreshed the page. In the following question, there might be several possible answers, several possible correct answers for the same question. So don't be surprised. Let me wait a little bit more for people to rejoin. Okay, so question number 4. What are the use cases for access to raw encrypted information? Maybe that would be useful if you want and need to move encrypted files between different file systems and without the need to decrypt and then re-encrypt stuff every time. Maybe it's useful for backup restore or Lustre HSM, or just hack to metrics, just for fun. So there are 3 correct answers to this question. Okay. Oh, Stefan. Question number 5. What are the security risks of exposing raw encrypted information? First risk would be to be hacked by Neo from the matrix. Another risk would be to leak precious information. Maybe it would give the ability to corrupt files, or maybe there is no real security risks in doing so. And the correct answer is there is no security risk in exposing raw information. That was a tough question, I realize. Okay. Question number 6. This is, again, a bonus question, double points. What are the security risks of backing up encrypted files in clear text? So maybe you could be hacked by Kevin at 12. Maybe you could be exposing private information by doing so. Maybe it's a problem to make clear text copies. Or maybe there is no security risk in making clear text copies. And again, there were 3 possible answers for this question. Okay. So after 6 questions, let's have a look at the current ranking. Okay. I cannot see the others, but keep up the good work. There are 3 more questions to come. So first, let's debrief that. So we have identified 3 main use cases that would require having access to raw encrypted information. The first one is, let's imagine you have a cloud infrastructure with your data, and then you have a Scratch file system, and you have encrypted files that you need to move to your Scratch file system in order to do some computation. And in this case, you might want to avoid as much as possible reading the files, which means decrypting them and then rewriting them, which means re-encrypting. So that would be smoother to be able to copy those files without the need to decrypt and then re-encrypt. The other main and obvious, let's say, use case is to be able to back up and restore encrypted files without the encryption key. It's important to do that without the encryption key because these are encrypted files, so we definitely don't want to make clear text copies of those files. And the same goes for Lustre HSM. We might want to use Lustre HSM with encrypted files on the Lustre file system, but again, without the encryption key to prevent making clear text copies on the cold storage. Problem is, for FSCrypt forbids all that kind of accesses. But the thing is, there are no security risks if we have access to raw encrypted information. Raw encrypted information is useless without the key. This is the reason why we encrypt, right? If you have an encrypted flash drive and you drop it in the street, well, you've lost your drive, but nobody is able to read what you put on that drive. And the same goes here. Obviously, you might not want to store your master key along with the encrypted files that you've backed up. So that's common sense. The encryption context in itself does not contain any valuable information. It contains 16-byte nonce that is used in combination with the master key to derive the per-file key. So once you have derived this per-file key, you can have access to the clear text content. But again, if you're not storing the master key along with the encryption context, there is no security issue. The only risk, but it's not a security risk, the only risk is to corrupt your encrypted files when you write to them without the encryption key. If you write some bytes in the file, it might end up, you might end up getting garbage when trying to reread this page, but this is the only user error that we can identify here. Okay, so this is the last part of the quiz. 3 remaining questions. So I will let you join or reconnect. Okay. So question number 7. Do you think it is possible to revert back to raw encrypted name from presented name? So imagine that you are accessing and listing files without the encryption key on your Lustre file system, And do you think it's possible that the presented name can be used to revert back to the re-encrypted name? Always, never? Maybe it depends on the name length, or maybe it depends on the bytes that are in the names. And so the right answer is it depends on the name length. So we will get back to that just later. Okay. Oh, no points were scored by the leaders. Wake up, guys. Question number 8, where is stored the size of an encrypted file? So they think we are using a specific extended attribute on MDT object. They think we are using a specific extended attribute on OST objects. Maybe we repurpose the LSOM extended attribute, or maybe we just store size as with normal unencrypted files. And the correct answer is we just use the same mechanism as with normal raster files. Okay. Last question of the quiz. Again, bonus question, so double points. Do you think there is any difference between the encrypted file size seen with and without the encryption key? So imagine that you are starting a file with the key, you see a size, you are starting the same file without the encryption key. Do you see a different file size or not? Maybe it's rounded up to 4K, or maybe it's just the same size you can see. Wow, that's a split. And the right answer was it's rounded up to 4 kilobytes. Okay, so let's debrief these last questions. So first question was about the raw encrypted name. When you browse your encrypted directories without the encryption key, you see scrambled names. And those names, for short names, these are raw encrypted names that are just base 64 encoded. So in this case, you can consider that you would be able to revert back to the encrypted name. But for longer names, it's actually a digested form that contains only a portion of the raw encrypted name. So this is to say we cannot count on the presented name without the encryption key to think that we will be always able to get the raw encrypted name. Also, without the key, when you browse your encrypted directories, the file sizes are rounded up to the next encryption boundary. So in the quiz, I said 4 kilobytes because the encryption unit size we use is 4 kilobytes. And we are doing this roundup. And for instance, if you read the file without the encryption key, it will let you have access to the whole pages that are encrypted and not just the bunch of it, a part of it. But still, we need to keep track of the clear text file size. It cannot be inferred from the raw encrypted content because raw encrypted content is full encrypted blocks. And this clear text file size must be restored, must be set back to the files when we restore them. Last comment is about the encryption context. Obviously, we need to save this encryption context if we want to have later access to the clear text content and name. So what we propose to address this limitation is to present a virtual new extended attribute specific to Lustre that we would call security.encdata. And this extended attribute would contain all the information we need for the different scenarios I was describing earlier. So that would contain the clear text file size, the encryption context, and the raw encrypted name. For backup and restore, we would have to modify the tar utility. And for Lustre HSM, we would have to modify the POSIX copy tool, simply because in case those tools are dealing with an encrypted file, they would have to explicitly fetch this extended attribute. We do not want to expose this extended attribute when, for instance, you list all the existing extended attributes. And the other thing is that those tools would always need to use specific open flags because we do not want any application to be able to open encrypted files without the encryption key. You have to set specific flags explicitly so that you are allowed by Lustre to read and write content in the file without the encryption key. So as a conclusion, we can say that Lustre 2.15.2 has full encryption support, content encryption and name encryption, with a pretty good performance level. We have identified limitations with the feature. That was just a sneak peek at what we want to do. There are ongoing discussions with the other Lustre developers in the community to find the best solution possible in order to address those limitations. So this is really the early stage and the design stage that is happening now. And that's all for this presentation. I hope you enjoyed it. I hope you enjoyed the quiz as much as I enjoyed preparing that. So I think this is the time to have a look at the final ranking and see who won a free drink for tonight. So in number 3, we have Seth Pichowski. Congratulations. Number 2, Simon. Who is Simon? And number 1, this is Guillaume. Okay, and in number 4, we have Stefan, and I could not see the number 5, but congratulations, and thank you for participating, and I hope you enjoyed and to have something more interactive than we have usually. Do you have any questions?
Thank you, Sébastien.
Sure.
Any questions?
I'm just curious about these performance penalties for the encryption stuff. Are there ways to mitigate the performance? As a more metadata servers, more OSS servers, or stronger compute nodes, or what? How to mitigate it?
It's really, so the performances are really bound to the compute power on the client. Well, it's really bound to the client, so compute power and extra operations that need to be carried out because we are handling encrypted files. So if you look at the performance graph here, you can see that without the performance optimization, the performance drop was more like 20%. So obviously, we are doing more work when we need to encrypt or decrypt files. And as this optimization suggests, the main pain point was allocating pages to carry out encryption. So this is how we managed to reduce it to an acceptable level. So here you have the performance with for write bandwidth, sorry. And maybe I have some backup slides. Yeah, here you have the read bandwidth performance, and as you can see, the performance drop is around 5%, so which is pretty nice. And here you have metadata performance, so again, a pretty reasonable performance impact to have names encrypted.
Yeah, it's important to note that this is the performance limitation is only, that's a single client performance. And if you have any kind of bandwidth limitation on the network or the servers, then there's no overhead at all. Yeah. Because if the clients are, doing the encryption faster than the servers can process the data, then there's no overhead on the servers from the encryption. It's just raw data to them. And so there's no overhead at all in that case.
We can say that these performance numbers are for worst case scenarios where this is really a single client that is limiting the overall bandwidth, but it rarely happens on production clusters daily.
Any other question? I have one, Sébastien, about CPU performance. Have you got measure the CPU resources impact with encryption and without encryption it's cool to have numbers on throughput. But about CPU resources, have you got a number?
Yeah, of course. When you do encryption, you're worried that your CPU power is used not for computation, but for encryption. So I haven't numbers here, but really the performance after this optimization, the performance number impact was more because of the the extra operations that are being carried out in Lustre. So CPU usage was not like 80% or something. No, it was pretty reasonable. But I'm sorry, I do not have exact numbers. But it's not huge. And so this API, the FSCrypt API provided by the kernel and that we embedded in Lustre, uses AES algorithms. So most modern CPUs, Intel CPUs, have hardware acceleration for this. So this is not a big deal.
Cool, thank you. Any other question? Perhaps online? No question online. Okay, thank you again, Sébastien.
Sure.
So now we are ready for our next speaker, which is the first break, a cat break. Thank you.
Guys, time is over. Come in, please take a seat. Time is over, guys. Come on, come in. Take a seat. So we are going to start with the next talk, which was done by Artem. I don't know if you are online, Artem, but we have a spare speaker. It's up to you, Guillaume.
Right, so Andreas will make the presentation of Artem. So Andreas has been involved in Lustre development since its inception, from early prototypes in 2000 through several companies over the past 20 years. Andreas has been one of the lead Lustre developers. In 2012, he took over the role of Lustre principal architect, and since 2010, he's Lustre CTO at OneCloud DDN.
Thank you. So I'm presenting on behalf of Artem, who's a longtime Lustre developer. He's mostly focused on LDiskFS and E2FS progs, but has contributed to other areas of Lustre as well. So today's presentation is about improvements to LDiskFS, and in particular focusing on the multi-block allocator. This is particularly important today as the size of OSTs is growing quite large. We're regularly seeing OSTs in the 500 terabyte range, and growing up to be 1 petabyte in some cases or more. And I mean, from my point of view, the first Lustre file systems were under a petabyte, and so to have 1 OST, that's pretty amazing. So the multi-block allocator is was developed at Cluster File Systems many years ago, and its goal is to efficiently allocate large chunks of disk rather than the old allocator would allocate 1 block at a time, and multi-block allocator obviously allocates multiple blocks, and it's used for larger I/O sizes, and it works essentially by a multi-stage selection process. First, it locates a suitable group in the file system, and with these large file systems, I mean, a petabyte OST has 8 million allocation groups, and so first it has to find an allocation group, and then it has, it's called a buddy bitmap. It's a power of 2 bitmap that allows you to efficiently, just through bit scanning, find the largest free chunks of space in the disk, in that group. And so, as all things, it's supposed to be, newer things are always better, but in fact, we've been seeing as the OST size grows, we do have some issues with the allocator in LDiskFS. You know, we've seen that, you know, with large OST sizes or fragmented file systems, we can have high latency for block allocation. And the other problem is that it has sort of a round robin nature. Like we tried to, you know, not use allocation groups for a long time so that they can get the maximum amount of blocks freed out of the group. But with spinning disks, you find that you know, at the end of the disk, you know, the physics dictates that you know, the higher block addresses are closer to the center of the disk, and so the linear velocity at the inside of the disk is lower and lower bandwidth. And Upstream has been doing some work on ext4 MBALIC as well, but it also had some problems, and so you know, both of them need some development effort. And so the basic idea behind MBALIC is that it's, you know, in the, you know, left side, you can see, you know, we tried to allocate, you know, from the free parts of the disk, and this works good, you know, while the disk is relatively empty. The allocation window, you know, we do forward scanning, and so that works while the disk is relatively unfragmented. But as time goes on, you get, you know, free space fragmentation, and then it has to do a lot more work to find the free space. And so, in fact, you know, with 8 million groups, it's not just a matter of, you know, doing the in-memory scan, reading off the bitmaps and things from the disks is, you know, 8 million IOPS, and at, you know, 100 or 200 IOPS per second, you know, that's can be 10 minutes after a mount to read all of these groups. So that can take too long. So there's a few mechanisms that we have at our disposal today to improve that. One is there's an interface pre-alloc table that, well, there's two things. One is there's a proc interface MB groups that dumps the buddy bitmap that can tell you what the distribution of free space is and how big the free space is in each group. And so that table can be very long, 8 million lines, but it can be processed in user space and then use it to tune group selection so that you don't spend time looking for groups with lots of free space when in fact there aren't groups that have, you know, 16 megabyte free chunks anymore. And so this needs active participation from a user space tuning, and doesn't always work. The way that MBALIC works today is essentially 4 passes, right? The first pass, criteria 0, means it looks, you know, for the optimal allocation case. I mean, Lustre is already doing the write back caching on the client, and so we do have fairly good I/O aggregation if the applications are well behaved. And so, you know, RPC size can be 4 or 16 megabytes up to 32 megabytes. And so when we send the large RPCs from the client, they're aligned, you know, to the logical offset of the file in you know, 4 megabyte multiples, for instance. And so that works well with aligning those to the disk. And so in the first pass, we tried to find aligned chunks of free space that you know, will also align like with RAID stripes and things in the underlying storage. And if the CR0 pass doesn't find anything, you know, we go to CR1. It tries to find a group that has, you know, an average free space of, let's say, 4 megabytes. And so that would mean, you know, there will be some spaces, some groups that have more, you know, than 4 megabyte free chunks. And so those are suitable. But again, if it does a pass with CR1, it doesn't find any groups. You know, it just tries to find any group that has enough free space. And finally, If that fails in CR3, it will fragment the allocation among multiple groups and just use small free space. And so this is a problem as file systems get, 80 or 90% full. There aren't very easy choices for finding allocation space. And so, maybe in Lustre 2.12 or 13, there was essentially a patch added to allow a skip threshold so that, instead of looping over, all 4 million groups in a file system or 8 million, it says, it's unlikely for me to find, an excellent allocation quickly, so I'm just going to skip the first loop and start looking right away for a group that has an average free space. It'll start at the CR1 loop and try and find an average free space in a group and then do the allocation within there. So you would know that if the average free chunk size is, at least 4 megabytes, there has to be somewhere in that group a chunk that is 4 megabytes or more. And similarly, let's say after, if there's only 15% of free space left, it'll go directly into the CR2 loop, et cetera. And so, this avoids a lot of in-memory scanning and speeds up the allocation at the cost of, not having as good a allocation choices. And so one of the problems that we found was that, this is great for testing, but there isn't a persistent way to set it. So we added in a mount option, and there isn't a tunable parameter, but we would like, to use the normal Lustre set param and set param minus p to be able to tune that. So we had to add, or we haven't done this work yet, but we want to add in the ability to tune parameters under the LDiskFS, sysfs, LDiskFS, and procfs. Because currently we just look in procfs Lustre and sysfs Lustre for tunable parameters. But that should be relatively easily done. And so you can see for this tunings here for the C1, C2, C3 thresholds, you can see when that is needed, right? By there's the MB stats, the multi-block statistics. You can see that, in the left case, it has this counter useless loops counter. And so in the right case, you can see, these thresholds were tuned too low, and 4% free space, 1% free space. And so what happened was, the allocator is spending a lot of time, looking for free space with criteria that can't be matched by the file system. And so, you see these 1 million, 2 million count of useless loops. And so, those thresholds have to be adjusted higher so that, it's spending its time effectively finding free space. The other issue that is, causing problems with, especially with these large disks, is, allocating space at the end of the file system. So we have this MB last group counter, and so, that records the previous group that was used for allocation. And so this round robins, just increases until it hits the end of the disk and starts at the beginning. And so the reasoning behind that was that, if you're allocating in a forward direction, it's fairly efficient, and then that gives the maximum time for the files behind the MB last group to free up space in the file system. And so that's good, but as you can see, there's this large range of blocks that have been freed at the beginning of the disk, and those can be 20 or 30% higher bandwidth, and so that's pretty significant compared to the last part of the disk. And so what we would like to do is reset the counter to the beginning, but only when there's space that's freed, right? Otherwise, if we're always allocating at the beginning of the disk, then, we're spending a lot of time rescanning the full part of the beginning of the disk. So you can do this manually, but it's not, just write 0 into this MB last group counter, but that's not something that happens in production. That's, more of a benchmarking kind of thing to do. And so, you can have a user space script that monitors free space again, but that's not, very automatic. There's lots of things you can do, but people don't because they don't know they need to do it. And so it's more important to get it done automatically. And so there is some work being done. I think it comes up in a later slide, this LU14438. It's a patch that's been proposed by HPE to do that. So, as I mentioned earlier, one of the problems with so many metadata groups for allocation is that the mount time can be very long, right? So if you have 8 million groups, we did have a problem. As soon as an OST mounts, it contacts the MGS to get a new configuration log, and then the first thing it tries to do is, allocate, 64K or whatever of space to try and write out the new configuration log. And so it was scanning, every single group, using this CR0 criteria. It took, reading all of these bitmaps can take 10 minutes, right? And so that, hurt your mounting time significantly. And so, we've put in special cases to avoid, trying to find a perfect allocation when you're doing a small allocation like that to speed up the mount time. But again, that's kind of a hack. So essentially what we've done is if you're mounting up the file system and you haven't read all of those groups, then don't bother trying to read all of them from disk. Just try to find one group that's good enough and has some free space, and then allocate immediately from whatever's been loaded into memory. And then we have essentially a background thread that runs after mount, and it goes ahead and prefetches all of the bitmaps from disk. And so that doesn't delay the mount, but eventually we'll read the metadata into memory so that it can be used for allocations afterwards. And so this, there's a new allocation heuristic that's being worked on by HPE that's trying to bias allocations towards the start of the disk to avoid, using the slow end of the disk if that isn't needed. And so this is still in development. But, there's discussions going on about this to, they have essentially trying to balance between, trying to do all of the allocations at the beginning. So if they have this KLTA rate, and, they said, in theory, if KLTA rate is 100, it means that the beginning of the disk has to be 100% full before we start allocating, after the start of the disk. And so that's, not a reasonable parameter, but it's just shown here for illustration purposes. The default rate at 25 means that, if the beginning of the disk is 25% full, then, it can extend out the allocation region, and so it has a sum of a balance between keeping allocations at the start of the disk, or, using the later parts of the disk. And so, in the example here, the file system is 22% full. They have this KLTA rate of 25, and so it means that when it's 25% full or less, then, if you've scanned, to the MB last group has hit, 88% full, right? So that's 22% of the file system divided by the rate. It will reset to the beginning and try and prefer allocations from the beginning of the disk. And then because, performance is not a linear function of the offset in the disk, they have a KLTA start parameter that says, the beginning, whatever fraction of the disk, 10%, is considered to have linear performance, and only the end of the disk has a declining performance. And so you can bias it so that it the beginning of the disk is treated equally well. And so we still have discussions on this. It's not quite sure what the right parameters are, but it's one option. The other thing, in the upstream ext4, they have done some work for this MB optimized scan, which is, instead of doing a linear scan across the disk, they've introduced an array of free order blocks, right? So that they have an array of 128 meg chunks, 8 meg chunks, 4 meg chunks, 2, 1, all the way up. So if you're looking, and as an allocator, you're looking for an 8 megabyte chunk of free disk, you can do an order 1 lookup in this table to find a group that has 8 megabyte free block. And so that's very efficient. Then they also have a separate RB tree that they use for searching in CR1, so that you can find average free groups. It turns out that the RB tree has a bit too high of overhead, and so what they're doing in the patch that hasn't landed yet in the upstream kernel, they're replacing the red-black tree with another array. And so that will also give order 1 group selection. And so this is good, but it doesn't solve the problem of beginning versus end of disk. And so we do need to do something in that area. What we can do is try and bias allocations towards the start of the disk in the lists, so that we can put, currently it has a bug that it inserts the entries in reverse order, so it actually biases everything to the end of the disk, and so that needs to be fixed. But we can decide, if you're, in the first 75% of the disk, insert that at the front of the list, and if you're in the last 25% of the disk, insert that at the end of the list, and so that would, relatively easily balance the performance. And so, this came up, the performance problem with the MBALIC came up not because of huge storage like we see in Lustre, but because of very slow flash devices used in embedded handsets. They actually found the same kind of problem because they had lots of erase blocks, and the MB optimized scan was allocating too widely across the disk, and so that was hurting the allocation performance. But so there's a few things that are in flight, but it's a problem that we're very interested to address, just because of these the demand for such huge OSTs, and it'll be in one of the near upcoming releases we'll have something to address these issues. So I think that's it. Any questions?
Thank you. Question?
About the MB stats, where you could see at what point you would need to do some tuning maybe. When do those reset?
The MB stats. Well, I can't say for sure. Obviously at boot, or remounting. I don't know if you can write into this one to reset them. And normally in the Lustre tunables you can. If you write anything into a Lustre tunable file, it will reset all of the counters, but I can't say for sure. But this would probably be from the time of boot,
All right, thanks.
or mount, I should say.
I think it's a DiskFS module mount. Any question?
Okay.
One. Thank you for this exciting topic. Yeah, for sure. I believe that many people who are going to understand why when you have a large OST and when you have some data and after some days when we try to mount, for example, this OST takes pretty long time and you have the explanation. Thank you. Yeah? Soon. soon. It's already online. Thank you.
Okay, so our next speaker is Torben Peterson. He's a distinguished technologist at HP and a lead HPC storage architect for EMEA and APAC. He's worked with Lustre in one form or another since 2007 in companies such as Sun Microsystems, Oracle, Xerotex, Seagate, and Cray before joining HP. Torben works for the HPC storage business unit and is involved in everything from solution design, customer acceptance, to defining next-gen HPC storage for HP.
Thank you. So by that, I'm actually not a developer, so everything you heard so far is from developers who actually knows Lustre. I just use Lustre, which is kind of a different thing. Secondly, I was asked to do something slightly different. So this talk doesn't actually speak directly to Lustre and Lustre functionality, but how Lustre fits into a larger ecosystem. And it is, unfortunately, I would say, partly the view of HP, which means that it's really hard not to speak about products, but I will do my best not to talk about anything that comes out of our portfolio. But this is more about the way we see the future of Lustre fitting into our customer sites, our customers' requirements, and so on and so forth. Specifically around the way, how do you manage data for a lifetime? And part of that is because that should have been a build-up slide. So is this in PowerPoint? Well, obviously something doesn't work. Okay, I can do that anyway, but it's supposed to be a build-up slide because you kind of want to show you what our typical customers look like today. And those customers are not necessarily the customers like Oak Ridge with a 700 petabyte single namespace and those kind of things, because those guys actually know what they're doing. We don't actually need to help them. Actually, they need to help us, and sometimes because they see problem at scale that nobody's seen before. But we also have a lot of customers in the commercial space or in the less typical space. I mean, we even have a customer that has a Lustre file system that's called Zalando. Now, you wouldn't say that as an HPC type customer, but they still have a file system we need to fit into our environment. So the idea here is we are living in a heterogeneous society today with regards to compute. We have our compute nodes today, which we always had. They're now very complex compute node with a lot of GPUs and a lot of other accelerators, different architectures from a CPU point of view, and so on and so forth. There is good. Good. And one of the things we've been trying to do is accelerate certain things by adding storage to the compute nodes. That storage could be in the form of 3D XPoint. And yes, I know Intel has just canceled future development of 3D XPoint, but it's going to be around for another 3 to 4 years. And it will most likely be replaced by something similar that can give us those accelerations. Now, the problem with node local storage is that it doesn't actually allow you to share that storage, which is why Deos, for instance, have come into the picture. So Deos allows us to build a file system covering multiple nodes and be in parallel access to that file system. We can also add local NVMEs to a lot of nodes, which is also done frequently, but those nodes are unfortunately very node specific. There are things we can do that, and I'll get to that in a second, to enable that as well. But that's how the compute side looks. Then we have our parallel file systems, whether that be Lustre, whether that be SpectrumScale, which still has a lot of legs in it, despite the fact that it's a commercial product from IBM. And we are now seeing more and more NVMe fabrics coming out. All of these things need to act together in a way where we can actually use that data in an intelligent and balanced fashion. But the problem with the file system today is we see more and more what I call tiered file systems or hybrid file systems, depending on how you want to slice and dice the OSTs from the OSSs. And that means we have a flash tier and a disk tier. In some cases, we have multiple flash tiers because they're formatted differently. They could be RAID 10 and parallelly clustered RAID in the same file system. You could have disk tiers that are used for capacity. You could have disk tiers for performance. So you can have very complex file systems. And one of the last things you want to do is consistently and continuously move data between the tiers in an unstructured fashion. It has to be intelligent. That's what we call data services. And that's both about data placement, but also about data movement or migration. And that's a really important component. And then on the right-hand side, we have our archiving system because, strangely enough, people want to save their data for a long time. Some of our customers save their data for 30, 40 years, which unfortunately means, media migrations over and over and over again, which is another hard part to do. And all of this is tied together nowadays with really, really fast networks, usually based on HDR, 200 gigabit Ethernet, with Rockies becoming a good second to that. And obviously we have our own Slingshot, which again is an Ethernet type fabric, but different management. Now, when you have all of these things together, you need to be able to not only allocate data to the right place at the right time, you also need to be able to move it from a lower tier to a higher tier in anticipation of a job. And that job needs to have that data available at the right tier when that job runs. And if that wasn't enough, you also need a third thing, which... So this is actually not my last presentation. This is not a good thing. So the one I sent on Thursday is not this one. Okay, doesn't matter. I may be missing some slides. I realize that there's supposed to be something on top here as well. Honestly, I need my presentation. This one has so many slides that I've redone. This was the PTX, the PowerPoint one? I sent over on Thursday. The last one was called Final. This is not the final one.
Final one?
No, there's only
Perhaps it will be better, this one.
Actually.
It's okay for you?
Yeah.
Okay.
That's one with animation. So let's speed through this animation until we get to the end. Because one of the things I wanted to mention here is the fact that I forgot about that part. We can now actually use that using persistent client cache, or LROC is called in the SpectrumScale world, which is obviously a new way of handling data as well. But that's not really an important thing. The important thing is this. We're getting to a situation where our file systems are growing to huge sizes. Very few customers has just one file system in there. They have a mixture of different file systems and different tiers. And we need to be able to not only manage this as one big entity, we also need to be able to have tools that can manage the data in there. That means we are creating what I call a single virtual namespace that covers all of the different aspects in there. Because as a user, you need to be able to ask your file system, where is my file, and not get one file back. But you could get a list of files, and you have a file that's located on Deos. You have a copy of that file that's located on Flash here. You have a version of that file or two that's actually located on HDD. And you've got 4 backup copies on your tape. because that's how you manage your file, your data. And that needs to be automated, right? The next slide is really only about why we need this. And again, as I say, some of our users are using humongous data sets that needs to be reused over and over again. It's not just scratch data anymore. And that's really important to remember. It is dynamic data being used and reused for reference purposes. And that could be anything from our customers at Airbus, where whenever they need to service a plane out on the field, when they have a problem that affects a plane standing at a gate, the service engineers in Toulouse needs to be able to access every piece of support data for that exact plane. Not the type of plane, but that exact plane, which is located on tape today. That means it could take up to 30 minutes to get that data ready. And at that time, the plane is just sitting at the gate, passengers in the plane, if we are unlucky, and it costs a fortune for every second of delay you have. If you can speed that up by an order of 10, that is money in the bank directly. And we all have similar type of situations out there where this is needed. So data management and data mobility is really important. Now, so my first bit here is about intra-file system data mobility. How do you manage data inside a single namespace when you have a flash tier and a disk tier? And again, we are using a lot of the features in Lustre. Now I'm specifically focused on Lustre. So, the progressive file layout is one of the biggest advantages I've seen in modern time, or in the lifetime of Lustre, I would say, which I think is one of the most useful things we've had in a long time. File level replication is still a bit immature, but we are using it. But very few customers are. And why is that? Because it's hard. It's not that easy to do it systematically. If we have a tool that can do that for you, it will speed things up. It will enable users to focus on what's really important, i.e. using the data, not managing the data. And some other things. But Lustre lacks a lot of these components today. Yes, you can do a manual data migration using LFS Migrate and so on and so forth, but it's not really a very efficient way of moving data around. So what we come up with is a solution we call data services. Again, we're trying to use open source tools, but we're also trying to use some modern technology. So this is actually based around a Kubernetes environment with three nodes in a cluster in order to manage these things consistently over time. But what's important in here is the services. So if we look at the right side here, or left side here, we have our basic file system with a flash pool and a disk pool. Obviously, there is data on metadata or data on MDT as well on the metadata servers, but that data is so small that we shouldn't really focus too much about it. And it's usually static. It doesn't move very often. And then on the right, we have our cluster. Now, Lustre doesn't know that that cluster is there, but the cluster knows about Lustre big time. And inside that cluster, it does a number of things. First of all, it does indexing of the cluster. It creates a mirror copy of the metadata. But it doesn't do that in a database because databases are slow inherently. And we need to be able to do hundreds of searches on that data in a complex way per minute, easily. And that needs to be done without affecting the performance of the Lustre file system because we still need that to run at full tilt. Once I have that mirror in index files, and by the way, those index files are stored on the Lustre file system, so we have parallel access to it. And it's also obviously on the flash tier, so we can access it really quickly. And it can be handled by accessed by multiple nodes at the same time. Again, parallel access to those flat files. That means I can read those files really quickly, I can update them really quickly, and I can utilize them both in a static state or in a dynamic state as my jobs pertains to it. Then we have a policy engine, or a search engine rather, that uses a number of queries to that, and uses SQL language to do so, because that's the easiest way for me to write very detailed queries on the data. But it's not an SQL database. That's really important to remember. After that, we have a policy management system, which essentially is based around the Kafka engines. We can do out-of-order searches and some other things with NQ and so on and so forth. It's really just using the best tool for the purpose at any given time. And then we have a tiering engine. Now, the tiering engine creates a just-in-time list of files to be moved and distributed to one or more data movers. And that's something we externalize. So the data movers here are actually dedicated nodes or embedded functions in the 3 core nodes that can move these data in parallel. And that means I can get really high data movements based on those policies. Now, those policies could be anything. I need to speed up a bit. The important thing is that whole hierarchy here can be accessed by a number of different users. So the end user can actually do a search on the file system using their own files. They will only see their own files that they have right to see, but they can use the same tool instead of using a find in Lustre, because this is 10 times faster than anything Lustre can do. It can be accessed, obviously, by system administrators, because they need to modify the policies, and the policies by themselves is also stored on the Lustre file system, so it's all encapsulated in one site. But we can also access this using a resource manager like Slurm or PBS Pro. That means that those jobs that we submit to PBS Pro or to Slurm can actually have a Prolog script that says, before I launch this script or this job onto my compute, I need to make certain that this list of data is put in at the right place, for instance in Flash. So it will actually find the data, no matter where it is in the file system, put it into a dedicated directory on the Flash tier. Once it's done, it can tell the resource engine, these data are now ready to go, you can launch the job. The job is then launched, it has access to that data in a dedicated spot on the file system, most notably in the Flash tier. And then once it's done, it has a PostScript that will migrate data to where it needs to be. And that can run in the background with no user interaction or no admin interaction forever. So the policies are really important. I mentioned the file search, I'll skip that for now. This is a standard policy. And some of you may think it's familiar because we're actually using Robinhood syntax. We're not using Robinhood because, honestly, Robinhood is too slow. It can't keep up. And I know some of you are developing that and like Robinhood a lot, and I do like Robinhood as well, but it's not fast enough to manage a file system like, for instance, the Orion file system at Oak Ridge, 700 petabyte, 60 billion files once they're done. That's no way a standard policy engine, read and changelog could keep up with that. So we use the same type of policies because it's easy to write and so on and so forth. So this is standard policy, just doing what we call flash maintenance. Any flash on the system that is more than 75% full get exposed to this. You can set the threshold yourself, obviously, and then it moves data off. Again, it uses the oldest and the largest files to move off unless they are sacrosanct, which means that they have a no migrate flag on them. And that's kind of one of the things we do with these systems. But it's not the only use case because we're still working with customers to figure out what the use cases are. We also have the use case of some other customers that just want to use this function, not for moving data, but for getting rid of data. Find old temp data that hasn't been used in 8 hours, get rid of it. Now, you can do that with any other script as well, but having a policy or multiple policies that can actually also identify location in the file system, not just the file name or the file type, but anything you can specify in metadata can be part of these things. That makes it a lot more flexible in our minds. This is actually what the whole system looks like. I won't go into any details, but I put it in there so you have the slides and can kind of see what our thinking are. And the idea here is just that these things are adaptable, they are manageable, they are something we can replace. There's really no proprietary components in here outside some of the code that we do on top of this. The rest is just, anyone could do it if they wanted to. I don't recommend it because it's been a pain in the neck actually getting it working, so you kind of get the picture. Now, the next thing I want to talk about is inter-file system migration, because that's just as important. And we have a solution called DMF. It's been around for a long time. DMF is something that would not only allow you to manage a Lustre file system. Originally, it was an HSM solution, but now we've migrated to also be a backup solution using version backups. And we can also do horizontal data movement. That means I can also actually take any of these file systems I have up here, whether it's spectrum scale, Lustre, external NAS, we can do DAOS, we can even do S3 front end nowadays. I can actually use a policy to move data from spectrum scale to Lustre, or from spectrum scale to S3, or from S3 to Lustre, whatever I want to do. Again, using policies. And again, it adds flexibility to that complex system I described on day one. Inside that, there is a lot of services running. And again, it creates a data center-wide view of all the file systems you have, all the files you have in those file systems, and gives you access to location and moving them to where you need them to do, or erase every single file from a user who is no longer part of the project, for instance, whether or not the data is on flash or on tape. In the back end, we can use almost any long-term storage component. We can even read PFS systems, keep mixing it up. PFS is unfortunately a product. The other one is the IBM. Yes, HPSS, sorry. There's too many acronyms in this world. I'm getting confused all the time here, right? So yeah, HPSS. It can actually read them. It can't write them because we use our own open source tool for doing that, which is called OpenVault. But we also have things like zero-watt storage. And that's exactly what it sounds like. It's big, stupid enclosures where we can actually spin down the drives. We use erasure coding between the different nodes to be able to safeguard data in case a disk doesn't come up. But essentially see that as virtual tape. But we can read data much, much faster than we can from an existing tape. We still use tape. Now, people know me says, I've been claiming tape is dead for the last 15 years. I've been wrong the last 15 years. I'd probably be wrong for the next 15 years too, because tape seems to be around to stay for a long time, because it's still cheap. It's not easy, but it is cheap. And then we have cloud-based solutions. I thought it was really strange when I had the first requirement to say that, oh, we need an archiving solution, but it should be based on Ceph. And I thought, why use Ceph for something like that? But it makes a lot of sense because you can have equal access to all of that archive by other means that Lustre doesn't provide. And so on and so forth. So that's a lot of options. Now, we have one tool that can actually handle all of these at the same time, which is important, because we can't have different tools for everything. Now, what does actually DMF look like? And I have one slide that explains it clearly. And it looks, yeah, I know what it looks like. That is actually the old version. The new version is much cleaner. We eliminated 3 or 4 boxes or something like that. But the important thing is that, again, we're using standard type of tools. We're using a shorter database, Cassandra, because, again, we need to be able to scale to sizes that handles multiple hundreds of petabytes or exabytes eventually. We need to be able to do intelligent searches on these data using Spark, for instance. We use our order engines like Kafka and so on and so forth. So that's nothing really unusual here again, because that's how we try to do things at HPE. So as much open source as possible, but package it in a way that makes it easy for people to use. And again, we have a big plan of moving this into what's now called the data mobility concept, because data migration or data management is no longer everything it needs to be. It needs to be mobility. That also means that adding multi-site replication, adding tools to be able to share data in a global fashion, again, dynamically, automatically, policy-based, is really important to us as well. And that also means we need to be able to access every single piece of client data out there, whether that is your standard change logs from Lustre, whether that is your index from Spectrum Scale, whether that's a NAS file system, we actually have to scan the file system actively to get the data. But that is really the key point of what we're trying to do. Create an environment where it's easy by using policies to set up a data migration, data management, data archiving, data locality, and so on and so forth, in order to get the data at the right place at the right time. And that also means combining it with the data services you saw earlier. So the evolution of this is actually getting to a point where we have one seamless activity that stretches from DAOs at the compute to dead tape property off premises in the other end, and it being one virtual namespace. So that kind of gets us to this point about what we're trying to do here, and basically one size doesn't fit all. That's why we try to do everything modular, everything dynamically, and not having to go all out on any of these solutions. So the smaller systems for either of these two solutions is 3 nodes, again for resiliency purposes, and they can scale to hundreds of nodes each. We haven't actually gotten to that point with any customers, but we have customers with about 25 nodes in a single cluster for one of these purposes, because it's needed for all of these different work steps and for delivering performance. Because moving data is not just about moving one file from one point to another. It's about moving, petabytes of data on an hourly basis in some cases, or at least a daily basis, from one tier to another. Whether that is just for archiving purposes, whether that is for restore and backup, restore and restart, checkpoint and restart, or something else. It doesn't really matter, because we don't dictate what the customers do with these systems, but we have to make sure that we can actually deliver the functionality they need in a supported manner. It also means that we can't write the policies for you. We need you to write the policies, and I'm happy to take part of them because that gives me new ideas what to do next. But I don't know every single workflow in the world. Actually, I probably know a fraction of the ones out there. And I keep getting surprised about some of the user workflows, especially now that we have then AI use cases and so on and so forth. That really makes things really difficult. And that's why we need that to be easy to manage by users. Databases or not databases? That's always a question. A database is nice, it's easy, but it has problems. And one of the last things I want to do is having to go to a customer and says, well, we can give you all of these functionalities and it can be in a nice, easily managed database. Unfortunately, you need to buy a mainframe to run that database because otherwise it will be too slow. Now, actually, we do sell those kind of mainframes at HP, but no, let's not go down that road. And finally, what do we do in the future? Now, we're trying to pioneer some new open source tools out there, like the common metadata framework. Again, it's not just for Lustre, but it's for an end-to-end management of those metadata, being extended metadata and so on and so forth. Because one of the biggest challenges we have with metadata is that I can find for a file, I can find a size, I can find a user or something like that. But what happens if I'm trying to find files created by users who are no longer with us for different reasons? They may have left the company, they may have passed away. How do I find their data without knowing how they name things? So we need more data to be able to look inside the files. Now, it's going to be really interesting if you go back to Sebastian's earlier presentation about not being able to access some of those data if you use client-side encryption, but that's not my problem. That's his. We're also looking at using some of the FAIR principles going forward. Again, how do I access data? How do I make it available? How do I make it reusable and so on and so forth? That's really important over time. And then finally, AI, machine learning and so on and so forth is probably key to make this work at large scale. I have no idea how we're going to get there yet, but it is something we're spending a lot of time on. So I know this was a lot of non-Lustre talk, but I wanted to kind of give you an idea about how we see the big picture and where Lustre fits into this component or this environment. And it is an important component because that's where the big performance is. None of the other file systems, maybe with the exception of Deos, that still has some teething problem, can deliver data as fast as Lustre. And it's still been the driving point of a lot of things we do. Performance, performance, and more performance. Thank you very much.
Thank you, Isabelle.
Any questions?
This close to lunch? I doubt it.
You wrong.
Hi. So I don't like to write policies. So does your product come with sort of GUI where you can drop boxes and stuff?
Not yet, but it is being discussed, yes.
Yeah, and the reason I'm asking is I've sort of, my experience is that the workflows it is something related to users, and a lot of users not particularly good at writing special stuff, and they would like to have boxes and put stuff inside the boxes.
Right. So one of those aspects I haven't been talking about, mainly because that's still kind of NDA in the company, is how do you automate policy creation? How do you create a policy based on monitoring a specific workflow? If that workflow is common, how can you actually snapshot that and put it into policy? Those are kind of things we're looking at. I have no idea how we're going to quite do that yet. That's one of the areas where machine learning may come in useful. But we are looking at how can those policies be set automatically by the system itself because it detects a common workflow. But again, it's early days for that yet. But we are trying to figure out a way, how can we help you write a policy that doesn't require you to actually learn the sometimes quirky syntax of Robinhood and so on and so forth.
Any other question?
Uh-oh.
You mentioned that there would be zero user interaction when setting up data before a job starts or something like that, but wouldn't the user at least need to specify, like, I want to access the files in this directory or something like that?
Yes, or you could use something like a product index, or you could use some other policies to actually define what those files are. It's not 100% foolproof, but it could be done as well. So we are looking at ways of how can we define data that should be reused, or how can we find a sample of data that should be part of that Prolog script to be pulled back. And again, it comes into the workflows and so on and so forth. In some cases, yes, you need to dictate things, but if you're a user and you launch a job into Slurm, for instance, you still need to define your files, right? Because if you want to run a simulation on a set of source files, you have to identify those source files and put it into the Slurm script submission any which way. So,
yeah, I've seen examples also where the file paths are hard-coded in some application. But
right.
So, yeah, users are lazy, and the less interaction they need to do with the systems, the better. A second question also, do you have already working integrations with Slurm where your framework can say, this job requested to move data, and now it's ready, so that Slurm knows to wait?
Yes, so we actually have that in the latest release of our product. So, and it's been something we've worked on for the last year and a half. And again, we're using standard message patterns for that as well. So it's not really rocket science. It's just how do you define when it's ready. But yeah.
Is that something which will be upstream to Slurm as well?
That's a very good question. I expect so. I mean, most of these components are open source, and we're trying to open source our own project, which unfortunately, when you work at HP, takes forever. But yes, that is something we're looking at.
I guess Slurm is GPL, so somebody will have the source code.
Probably, well, for the GPL stuff, yeah. But in our case, it's more a question about how do you do the scripts, which is not really Slurm. So.
Yeah. Okay. Thanks.
We have time for our last question.
The last question is, who's hungry?
It's my transition. Oh. Okay, thank you, Torben.
So before lunch, I would just bring you some information. It's for only live people. Okay, it's just to give you the link. You can try to copy-paste from the presentation. It's a bit hard when you're in remote, but you have copy-paste the link in the chat. So it's the place where you will see all LAD channel of this event. So enjoy the lunch.